Welcome to the video for C2.1.6 chromatography. So before we start this lesson, we need to remember from previous lessons the definitions of three terms. So we need to know that the solute is a substance that dissolves. A solvent is a liquid that dissolves another substance. So for example, if I take some sugar and put it in water and it dissolves, the sugar would be the solute and the solvent would be the water. And soluble means a substance that dissolves. So in this example, sugar is soluble in water. So our learning objectives for today, we need to be able to describe how paper chromatography, thin layer chromatography and gas chromatography work. And for paper chromatography or thin layer chromatography, we need to be able to calculate the RF values. So first of all, the three types of chromatography that we need to know about are paper chromatography, thin layer chromatography and gas chromatography. Paper chromatography and thin layer chromatography are very similar, so they're going to deal with those together. So both these two separate two or more soluble substances. So when we talk about chromatography, we always talk about phases. And a phase just means a solid, liquid or gas. So any form of chromatography is going to always involve two phases. And hopefully the names of these are quite self-explanatory. So a stationary phase means it doesn't move, and the mobile phase, which moves. So in paper and thin layer chromatography, we need to be able to explain how it works. So as we just said, you need a mobile phase and a stationary phase. So for paper and thin layer chromatography, the mobile phase is the solvent. So it's a liquid that dissolves the soluble substances that we're trying to separate. And that solvent, which is the mobile phase, will rise through the stationary phase and it dissolves the mixture, which then travels up the stationary phase. So you've probably done this in year 7, where you get a beaker and some water and some filter paper and you put some coloured ink on it. And as the water travels up the filter paper, it separates out into the different colours. So the diagram on the right shows one that's been separated. You can see on the baseline there's still some black there. That's just there to indicate that's what it looked originally in the real thing, because the components had moved up the plate. That dot wouldn't be there anymore unless there was something that wasn't soluble, and that would remain there. So different chemicals travel different distances up the plate or up the paper, and that depends on how much they're attracted to the stationary phase and the mobile phase. So if they're really soluble and they're not really that attracted to the paper, then they'll go a lot further. If they're not very soluble and they stick to the paper a lot, then they won't travel very far. So we need to know the differences between paper and thin layer chromatography. So if we drew a diagram of them, they'd look exactly the same. The difference is the stationary phase. So in paper chromatography, the stationary phase is paper. And in thin layer chromatography, it's a thin layer of silica or alumina on a strip of plastic or glass. You won't see these in GCSE classes because the silica powder that we use is quite dangerous. So you won't see these until we go to A-level. So the setup is, as I described before, you've got a beaker, you've got some solvent in the beaker. You've put if it's paper chromatography, it's just a piece of filter paper. That goes inside the beaker. You have the spot of the chemical that you're trying to separate. And then you allow the solvent to travel up the stationary phase, and that will separate out the substance into the different substances that it contains. So we need to be able to calculate the retention factor. So the retention factor is abbreviated to this RF, and the RF value we use to compare how far different substances have travelled up the stationary phase. But because the solvent will travel different distances depending on each experiment setup that we have, then the RF value compares it. So it's not just how far the spot's travelled, it's how far the spot's travelled compared to how far the solvent's travelled. So in the red box there, you can see the formula. You need to learn this formula for your exam. The retention factor is the distance from the baseline to the spot divided by the distance from the baseline to the solvent front. So we need to define a few terms here. So the baseline is, we always draw that in pencil, we'll get to that in a minute. So the baseline is where we've placed the original sample. The solvent front is how far the solvent has travelled. So you will allow the solvent to travel till it gets to normally about a centimetre from the top, and then you will remove it from solvent so no more goes up, and you'll draw a line in pencil to show where the solvent's got to. And then the spot is the point at whatever your part of that one substance that's part of your mixture has travelled. So we need to measure the distance from the baseline to the spot, and then we divide that by the distance from the baseline to the solvent front. Now, if two substances have got the same RF value, then they could be the same. We can't say they're definitely going to be the same because some substances will have the same RF value. However, if they've got different RF values, then we can say they're definitely different compounds or different substances. So sometimes in an exam you're asked about potential problems with chromatography. So first of all, the baseline needs to be drawn in pencil. If it doesn't, if we draw it in pen and that pen is soluble, then so the ink from the pen is soluble, then the ink will dissolve and run up the paper if it's paper chromatography, or the plate if it's thin layer chromatography. You have to stop it before the solvent reaches the top. If you allow it to go to the top and it keeps going, then some of the substances might reach, so all of the substances might reach the top and then they won't be separated anymore. The substance has to be soluble in the mobile phase. If the substance isn't soluble in the mobile phase, it will just stay on the baseline. And lastly, when you put the solvent in, you need to make sure that the level of the solvent in the beaker must be below the baseline. If it's not, the whole sample dissolves in the solvent and you just get a big inky mess. So on to gas chromatography now. I'm going to show you a diagram on the next couple of slides about what a gas chromatography machine looks like. But what I want you to do is watch the RSC video on gas chromatography. So you can either type in that URL into your browser or on the email that I sent you. It's got a clickable link. I've also sent you some questions that I would like you to answer about that video. So what is gas chromatography? Hopefully you've watched the video and you know. But if you didn't, stationary phase is, so we talked about stationary phase and mobile phase. So because chromatography, we need both. So for gas chromatography, the stationary phase is, again, silica or aluminium powder, just like or similar to the thin layer chromatography. But instead of being on a glass plate, it's packed into a metal column. And the mobile phase is an unreactive gas. So for example, nitrogen or argon. It has to be unreactive because you don't want it to react with your sample. So this is a diagram. I apologise for my lack of paint skills. This is a diagram of what a gas chromatography would look like. If you want a better diagram, there's one in your textbook. So you have your gas cylinder, that supplies your mobile phase. And that goes through the column, which is packed with the stationary phase. Now on that diagram, it's just a simple straight line. If you look at if you see the video or if you look in your textbook, you'll see that it's coiled so that it's longer. And that stationary phase goes through an oven. So you inject the sample where it says sample injected here. It only works with volatile substances. You've got an oven so that it keeps it in the gas phase. So the sample is carried through by the carrier gas, which is the mobile phase. It's carried through the column, and the more it sticks to the stationary phase, the longer it's going to take to get through the column. Now, the less it sticks, the more it's carried by the gas, the quicker it's going to get through. So you have a waste. The waste gas has to go out of the system, and then that's as the waste gases come out, it's analysed by a computer that analyses the signal and produces a chromatogram. And the chromatogram looks like this. So it will give you a detector response to say how much of that substance you've got. And it will also give you a time. So it's sometimes called the retention time or the travel time. It's how long it's taken to get through that column. And the important point here is that the area under the graph is proportional to the amount of substance. So the bigger the peak, so not just the height, but the broadness as well, means that there's more of that substance in that sample. Okay, that's all you need to know. Thank you for listening. See you next time.